5 minutes ago, scientists fed every single piece of data we have on 3i/Atlas into Grok AI. Every telescope reading, every trajectory calculation, every spectral analysis collected since the object was first detected. They asked the AI one simple question: what is this thing? The answer came back in seconds, and the room went silent. Not because the answer was wrong, not because the AI malfunctioned, but because what Grok AI said about 3i/Atlas does not match any natural object that has ever entered our solar system before. Not a comet, not an asteroid, not a fragment of a distant planet broken apart by gravity. Something else entirely. Something that the scientists running the analysis are still struggling to categorize using the frameworks they currently have. This is happening right now. The data is real, and the silence from NASA in the hours since this analysis was completed is telling a story that the official statements are not. To understand why this matters so much, you need to understand what 3i/Atlas actually is, and why its arrival in our solar system is unlike anything that has happened in recorded astronomical history. In the summer of 2025, a telescope in the Atlas Survey Network detected a faint moving object in the outer reaches of our solar system. At first, it looked like a distant comet, a chunk of ice and rock on an unusually elongated orbit. Astronomers noted it, cataloged it, and began routine follow-up observations. Then the orbital calculations came back, and everything changed. The trajectory of this object did not match any orbit that originates within our solar system. It was not coming from the Oort cloud, the vast reservoir of comets that surrounds our sun at an enormous distance. It was not a Kuiper belt object that had been nudged inward by some gravitational interaction. The math was unambiguous. This object came from interstellar space. It originated somewhere else, around another star, in another part of our galaxy, and it happened to pass through our solar system on its way to somewhere we cannot yet identify. The object was designated 3i/Atlas. The 3i stands for Third Interstellar Object. The first was Oumuamua, detected in 2017. The second was Borisov, detected in 2019. And now, in 2025, and into 2026, we have the third. But 3i/Atlas is different from both of its predecessors in ways that have made astronomers deeply uncomfortable. And when Grok AI was asked to analyze those differences, the answer it gave raised questions that nobody at NASA is currently willing to answer publicly. Oumuamua was strange. That is not an exaggeration. It was one of the strangest objects ever detected in the history of astronomy. Its shape was unusual. Telescope observations suggested it was extremely elongated, far more elongated than any known asteroid or comet, with a length-to-width ratio that some estimates put at 10:1. Objects that form naturally in space do not typically develop that shape. They tend to be more irregular, more rounded, shaped by the random violence of formation and collision, rather than by any consistent process. Its brightness varied in a regular pattern as it tumbled through space, flashing like a lighthouse as its long, flat sides caught and reflected sunlight. Scientists who analyzed that pattern concluded that it was rotating in a complex, tumbling motion. But even accounting for that rotation, the shape implied by the data was deeply unusual. And then there was its trajectory. As Oumuamua left our solar system, it was accelerating. Not decelerating as gravity from the sun should have been slowing it down, actually accelerating away as if something was pushing it. Scientists eventually proposed that this could be explained by outgassing, jets of material released from a comet-like body as it heats up near the sun. But nobody detected any outgassing. No coma, no tail, none of the visible signs that normally accompany that process. Oumuamua left the solar system before we could study it properly. We got glimpses, fragments of data, and then it was gone. Borisov was different, more conventional. It behaved exactly like a comet, with a visible coma and tail, outgassing as it warmed near the sun. It was strange because it came from another star system, but it was recognizable. It fit into existing categories. 3i/Atlas fits into no existing category. And that is what makes the Grok AI analysis so significant. When the AI was given the complete dataset on 3i/Atlas, it began with the same analysis that human astronomers had already performed, checking the object's trajectory, mass estimates, spectral composition, and behavior against known databases of natural objects. The trajectory confirmed what was already established. This object came from outside the solar system, moving on a hyperbolic path that will carry it through our inner solar system and back out into interstellar space. That part was expected. What was not expected was what the spectral analysis revealed. When light from a distant object passes through a spectrograph, it breaks into a spectrum that acts like a fingerprint. Different materials absorb and reflect different wavelengths of light, and by analyzing the spectrum of an object, astronomers can determine what it is made of. Rock, ice, carbon compounds, silicates. Each leaves a distinctive signature. The spectral signature of 3i/Atlas does not match any of the known categories cleanly. It contains elements and compounds that are consistent with what you would find in a natural interstellar object, but the proportions are wrong. The ratios between different materials do not match what models of planetary formation and interstellar chemistry predict should exist in a naturally occurring body of this type. Grok AI flagged this immediately. The AI ran the spectral data against every known database of natural astronomical objects, comets, asteroids, interstellar dust clouds, planetary fragments, and returned a probability score for how well the 3i/Atlas spectrum matched each category. Every category scored below the threshold that scientists use to confirm an identification. Nothing matched well enough to be declared a positive identification. That is an extraordinary result. When you point a spectrograph at a comet, it matches the comet category. When you analyze an asteroid, it matches the asteroid category. When you analyze 3i/Atlas, it matches nothing with confidence. The AI then did something that human analysts had not yet done. It looked for patterns in what the spectrum did match, not what it perfectly identified, but what combination of materials in what unusual proportions would produce the observed signature, and it found something. The spectrum of 3i/Atlas is most consistent. The AI determined with a processed material, not a material that formed naturally through the slow accumulation of dust and ice over millions of years. A material whose composition suggests it went through some kind of alteration, heating, compression, chemical processing, after it originally formed. That finding alone is extraordinary, but it is not what silenced the room. What silenced the room was what Grok AI said next. The AI was asked to extend its analysis beyond the spectral composition and examine the object's behavior as it moves through the solar system. Specifically, it was asked to look at 3i/Atlas's precise trajectory, not the broad strokes of its hyperbolic path, but the fine details, the micro variations, the tiny deviations from a perfectly calculated gravitational path. Every object moving through space is subject to the gravitational pull of the sun and the planets. Given enough data about an object's mass and position, you can calculate with extraordinary precision exactly where it should be at any given moment. If the object deviates from that calculated position, something is affecting it beyond gravity, either outgassing, as with comets, or some other force. 3i/Atlas shows deviations. Small ones, but measurable. The object is not exactly where the pure gravitational calculations say it should be. This by itself would not be alarming. Comets show trajectory deviations all the time. But the deviations of 3i/Atlas show a pattern that is difficult to explain through outgassing or any other known natural process. Natural outgassing deviations are somewhat random. They depend on which parts of the comet are heated as it rotates, and the resulting jets push the object in different directions at different times. The deviations average out in a statistical sense, and while they move the object off its pure gravitational path, they do not do so in a clean, consistent pattern. The trajectory deviations of 3I/Atlas are consistent. They appear to be correlated with the object's distance from the sun in a way that natural outgassing does not produce. As the object gets closer to the sun, the deviation changes in a specific, mathematically describable way. As it moves farther, the pattern changes again, but in a way that follows a formula rather than varying randomly. Grok AI analyzed this pattern and compared it against every known natural mechanism that could produce consistent trajectory deviations in an interstellar object, outgassing at different rates, radiation pressure from sunlight, the gravitational influence of the planets. None of them, individually or in combination, fully account for the observed pattern. The AI's conclusion, stated in the dry language of probability analysis, was that the trajectory deviations of 3I/Atlas are more consistent with a non-random, externally consistent force than with any known natural mechanism. In plain language, something is affecting this object's path in a way that behaves like a system rather than a natural process. That is the sentence that left the room silent. It is important to be precise about what this means and what it does not mean. Grok AI did not say that 3I/Atlas is an artificial object. It did not say that the trajectory deviations prove anything about the object's origin or nature. It did not make any claim that goes beyond what the data shows. What it said is that the data, as it currently exists, does not have a fully satisfying natural explanation. That the observed behavior of this object, its unusual spectral composition, its precise trajectory deviations, the specific pattern of those deviations, does not fit cleanly into any existing model of how natural interstellar objects behave. That is a scientific finding. It is not a conclusion. It is an observation that something about 3I/Atlas requires further explanation. But in the world of astronomy, that kind of finding carries enormous weight. Scientists spend careers developing models of how objects form and move through space. When an object shows up that does not fit those models, it means one of two things. Either the models are incomplete and need to be revised, or the object itself is genuinely different from what the models were built to describe. Both possibilities are significant. A revision to the models of interstellar object formation would itself be a major scientific development. It would mean that the processes that create and eject material from other star systems work differently from what we currently understand. That alone would be worth years of study. But the other possibility, that 3I/Atlas is genuinely different from any naturally formed object that has passed through our solar system before, is what the scientists in that room were sitting with in silence. There is context that makes this moment even more significant. Before 3I/Atlas was discovered, the scientific community had spent years debating the nature of Oumuamua, the acceleration anomaly, the unusual shape, the lack of visible outgassing. All of it had generated intense scientific discussion, and a small number of researchers had proposed, carefully and with full acknowledgement of the speculative nature of the idea, that Oumuamua might not be a naturally occurring object. Those proposals were met with skepticism, appropriate skepticism, because extraordinary claims require extraordinary evidence, and the evidence for Oumuamua was fragmentary and indirect. The object left before we could study it properly. Now, years later, a third interstellar object has entered our solar system. This one is larger than Oumuamua. It is moving more slowly, which means we have more time to observe it. The data we are collecting is more detailed, more precise, and more comprehensive than anything we got from either of its predecessors. And the AI analysis of that data is raising the same kinds of questions that Oumuamua raised, but with better data, more precision, and a clearer picture of what exactly does not fit. The scientific community will proceed carefully. That is the right approach. The history of science is full of anomalies that eventually turned out to have natural explanations that nobody had thought of yet, and the responsible path is to exhaust all natural explanations before considering others. But the silence from NASA in the hour since this analysis was completed reflects something real, not a cover-up, not a conspiracy, just the genuine uncertainty that comes when scientists encounter data that their current frameworks do not fully explain, and they are not yet ready to say publicly what the most careful analysis is suggesting. What happens next is already in motion. Every major telescope network that can observe 3I/Atlas is now pointed at it. The James Webb Space Telescope has been given observation time to conduct its own spectral analysis, which will be more detailed and more precise than anything ground-based instruments can produce. The European Space Agency is considering whether a fast response mission to send a probe toward 3I/Atlas is feasible. The object's trajectory has been calculated with enough precision to know where it will be, and the window to intercept it before it leaves the inner solar system is narrow, but may exist. More data is coming. More analysis is being done. The AI findings will be tested against every alternative explanation that scientists can generate. Some of those explanations may account for what Grok AI flagged. Some may not. What is certain is that 3I/Atlas is the most closely watched object in the solar system right now. Every photon of light it reflects is being collected and analyzed. Every deviation from its expected path is being measured and recorded. And somewhere in that data, in the spectrum of materials that does not quite match any known natural object, in the trajectory deviations that follow a pattern rather than a random process, there is an answer to what this thing actually is. The scientists who saw what Grok AI returned 5 minutes ago are still working on that answer. They have not spoken publicly about what the AI said. The observation logs are being reviewed. The calculations are being checked and rechecked. But in that room, when the AI finished its analysis and the result appeared on the screen, nobody said anything for a long time. Because what the data shows about 3I/Atlas, this object from another star, moving through our solar system right now, behaving in ways that do not fit any existing category, is something that none of them had a ready answer for. And in science, the moment when the smartest people in the room go quiet is often the moment when something genuinely important has been found. The answer is still being worked out. The telescopes are still watching. The data is still coming in. But 3I/Atlas is out there, moving through our solar system right now, and what it really is, may be the most important question in astronomy today. Consider for a moment the scale of what we are talking about. 3I/Atlas originated around another star. We do not know which star. We do not know how long it has been traveling. At the speeds that interstellar objects typically move, a journey from the nearest star system to ours takes tens of thousands of years. If 3I/Atlas came from farther away, from a star on the other side of the galaxy, the journey could have taken millions of years. This object has been moving through the darkness between stars for longer than modern humans have existed. It was already old when our ancestors first looked up at the night sky and wondered what the lights were. It was already moving toward us when the first human civilizations were building their first cities. And now, in this specific moment in history, in the brief window of time when humanity has developed the technology to detect it and analyze it, it has arrived. The timing is either an extraordinary coincidence or it is not a coincidence at all. That is not a scientific statement. Science does not deal in coincidences or their absence. It deals in data and probability. But as a simple observation about where we are in history, it is worth sitting with for a moment. For most of human existence, if something like 3I/Atlas had passed through our solar system, we would never have known. We did not have telescopes sensitive enough to detect it. We did not have computers fast enough to calculate its trajectory. We did not have AI systems sophisticated enough to analyze its spectrum in real time and flag the anomalies within seconds. We have those things now, and because we have them, we detected this object. We are watching it. We are asking questions about it that no generation before us could have asked. And the answer that came back, the one that silenced the room 5 minutes ago, is one that our current science does not have a complete response to. The question of what 3I/Atlas is will not be answered quickly. Science does not work that way. The process of confirming or refuting any extraordinary claim about an astronomical object requires months or years of observation, peer review, independent verification, and the slow accumulation of evidence that eventually tips the scale from uncertainty to conclusion. But there are things we already know, things that are not in dispute, things that the data, regardless of how it is ultimately interpreted, clearly shows. We know that 3I/Atlas came from outside our solar system. That is confirmed beyond any reasonable scientific doubt. The trajectory leaves no other interpretation. We know that its spectral composition is unusual, that the materials it is made of, in the proportions they appear in, do not cleanly match any known natural interstellar object. That is what the data shows. The interpretation of why is still being worked out, but the observation itself is not contested. We know that its trajectory shows deviations that do not have a fully satisfying natural explanation yet. Again, that is what the measurements show. Whether the explanation is a natural process we have not yet identified or something else entirely is the open question. And we know that Grok AI, when given all of this data and asked to analyze it, returned a finding that the scientists who requested the analysis were not prepared for. That finding is now being reviewed, verified, and challenged by every competing explanation the scientific community can generate. That is science working exactly as it should, not rushing to conclusions, not dismissing anomalies, asking questions, gathering data, and following the evidence wherever it leads, even when the evidence leads somewhere uncomfortable.
There is a history to this moment that gives it extra weight. When Oumuamua was discovered in 2017, the scientific community debated its nature for years. Most scientists concluded that it was probably a natural object, perhaps a fragment of a distant planet, or a type of comet we had not seen before, or something formed by processes that are common in other star systems but rare in ours. A small number of researchers proposed more unconventional explanations. The debate was real, and it was serious, even if the media coverage often made it seem more dramatic than the underlying science warranted. When Borisov arrived in 2019, it was a relief in some ways. It looked like a comet. It behaved like a comet. It confirmed that interstellar space contains cometary objects that are recognizable to us, that travel between star systems, and that sometimes pass through our own. The anxiety that Oumuamua had created was, for many scientists, somewhat relieved by Borisov's conventionality. 3I/Atlas has brought that anxiety back, not because of speculation or theory, but because of data. Because the telescopes are showing something that does not fit the categories we built after studying Oumuamua and Borisov and every other object that has ever entered our solar system. The scientific community knows how to handle anomalies. They have been doing it for centuries. Every major discovery in the history of astronomy started as an anomaly, something that did not fit, something that required a new explanation, something that eventually led to a deeper understanding of how the universe works. 3I/Atlas may be the same. Its anomalies may ultimately be explained by a natural process we have not yet identified. That is the most likely outcome, statistically speaking, because natural explanations outnumber unnatural ones in the history of science by an enormous margin. But the data is the data. And what the data shows, as of 5 minutes ago, is something that the most powerful AI system currently available for astronomical analysis examined carefully, compared against everything we know, and could not place into any existing category with confidence. That result will be studied. It will be challenged. It will be verified or refuted as more data comes in from more telescopes over more months of observation. But right now, in this moment, 3I/Atlas is moving through our solar system. It is real. The data is real. The AI analysis is real. And the silence in that room when the result appeared on the screen was real. Something is out there. We can see it. We can measure it. We can analyze it with the most sophisticated tools humanity has ever built. And we still do not know exactly what it is.